Okay, so this is meant to be an introduction to the lab that we're going to be doing this week. This lab is about identifying rocks. So some things that you'll have to be able to do in the lab. You'll have to make observations of your rock. You'll have to be able to say which type of rock your rock is, igneous, sedimentary, or metamorphic. You'll have to give evidence for why you chose that type. The evidence has to be something you can see in the rock, an observation. And then finally, you should be able to use your observations to make inferences about the rock's history. So for example, we've been learning about igneous rocks. In an igneous rock, small crystals means it cooled quickly. So the observation would be small crystals. The inference would be that it cooled quickly. Another example is if the rock is light in color or felsic composition, that means it formed on a continent. So what we see is the light color. What we infer is that it formed on a continent. So igneous rocks solidified from magma or lava. How do we know it's an igneous? Well, you should see evidence that the rock cooled in some fashion. So in this case, there's no crystals and glassy texture. So that glassy texture is a key because it means that that rock cooled instantly. We might also see big interlocking mineral crystals. Those big crystals, again, mean that it cooled really slowly. It took a long time for those mineral crystals to form. Now, I'm going to make sure that I write observations of the rock as my evidence, things that I actually see. I also want to write things that are specific enough to justify that I chose an igneous rock. So for that top rock, for example, I can't write black, right? The fact that the rock is black doesn't prove that it's an igneous. I can't write shiny because the fact that it's shiny doesn't prove that it's an igneous. So I chose words that gave evidence that the rock, evidence for my selection. So glassy texture, no crystals, or big interlocking mineral crystals. So sedimentary rocks form from the compaction and cementation of sediments or pieces of rock. So some things to look for are those rocks, right? So I might even say that, pieces of rock stuck together, or sand grains stuck together. The sediments were apart, and now they're together. You want to stick to something that you can actually see in the rock. And finally, for metamorphic rocks, since they formed when intense heat and or pressure changed the rock, you want to list something that you can see in the rock that gives evidence of that change. So in this case, we might mention something like foliation. So we're looking for minerals to be lined up. So foliation in this rock, it's hard to see in the picture. So when you're holding up a sample of this rock, this is a schist. The mica crystals are sort of flat and lined up in one direction. Those mica crystals also give evidence of the metamorphism because they're created when the rock is under that pressure. Right? We also call that mineral alignment. And the extreme version of that is banding or stripes. And so definitely when you see the striping, that dark light, that's evidence that the rock was under some sort of intense heat and pressure. So to summarize with these sort of cartoony pictures, let's start with number 3. We see the striping and the distortion. Those would give evidence that it's a metamorphic, right? We call that banding. We come over here to number 1. There's large interlocking mineral crystals. Those give it evidence that it's an igneous. Down on the bottom, number 4. Large rounded grains, sort of mixed in different sizes of grains, give evidence that it's a sedimentary. And in this last one, the small grains also give evidence of sedimentary if that were a sandstone. And if someone told me that that was an igneous with small crystals, I would say okay, because it's just a cartoon, we can't really tell. But, you know, sure, smaller crystals would also be evidence that it was an igneous. And that's the introduction to the basics of identifying rocks and giving evidence.